Sounds like we should, because we've got a lot of material. Okay, so Angela, why don't you go ahead and go to the next slide? All right. So everyone, thank you very, very much for joining us today. We're going to get started. While we wait for just one more minute as we get things going, please do feel free to join, add questions to the Zoom Q&A feature, join us on Twitter, visit the OpenSSF website. We've got all sorts of awesome training courses from OpenSSF, including free course on how to develop secure software. We'd love for people to take that. This tech talk is being recorded, so people will be able to get to this later, although obviously they won't be able to ask interactive questions later. So if you're watching this recording, thank you, and I hope you enjoyed this. Next. Okay, so here's our quick agenda here. My name's David A. Wheeler. I'm your moderator. We're gonna have some quick housekeeping. I'm going to introduce our panelists, to I'm very, very grateful. Thank you, all of you. They're each gonna have 5 minutes to present a little bit, things like introduction to GUAC, understanding GUAC, some insights. Then we'll have a little panel discussion, and then we'll take some, do some Q&A with questions from the audience. Next. If you're familiar with Linux Foundation, you've seen this slide 1,000 times. This is just a reminder that Linux Foundation meetings involve participation by industry competitors, and therefore it is absolutely necessary everybody comply with antitrust law, competition laws. If you have questions about this, there's a link with more information. So please, please, please do follow the laws, everyone participating here today. Thank you. Next. Oh, one more. Another is we do have a code of conduct. We're dedicated to providing harassment-free experience. Disagreement on technical issues is fine and completely expected. But that doesn't mean you get to harass people because of a disagreement. We're expecting everyone to behave in accordance with professional standards. For more details, see the code of conduct URL there. Next. Got questions? Wonderful. Please submit them using the Q&A feature on Zoom. Next. Okay, quick introduction for those of you who may not be familiar. The Open Source Security Foundation, or the OpenSSF, is, and this is a straight up quote, a community of software developers, security engineers, and more who are working together to secure open source software for the greater public good. It's a nonprofit foundation. It's part of the Linux Foundation. OpenSSF has lots of projects, many different efforts. Today, we're going to focus on one, the GUAC project. What's GUAC? Well, quick background. Team members from Kasari, Google, Citi, Purdue University have been dealing with the problem of software supply chain transparency. They decided to work together to try to find a solution, and they ended up building GUAC, which stands for Graph for Understanding Artifact Composition. We're going to learn a lot more in a moment about what that's all about. Next. So I now get to have the honor of introducing our panelists. This is a little bit about me. I'm David A. Wheeler. I'm the director of open source supply chain security at the Linux Foundation, but we're not really here to listen to know about me. So next, I'm going to straight up read from these slides because I think it's important to understand who our panelists are. First panelist is Rose Judge, senior open source engineer at Broadcom. Rose Judge is a senior open source engineer at Broadcom, formerly VMware, focused on open source security. She's the chair of the SPDX steering committee, plays an active role in developing both the technical and security profile specification. She's also an open source maintainer for Turn, a container SBOM tool, and spends the rest of her time in open source trying to improve gaps around SBOM creation, quality, and distribution. Next. Brandon Lum, open source security engineer at Google. Brandon loves designing and implementing computer systems with a focus on security, operating systems, and distributed parallel systems. Brandon's a co-chair emeritus of the CNCF Security Tag. As a part of the Google's open source security and BCID team, he works on improving the security of the open source ecosystem and observability into all of Google's software supply chain metadata, SBOMs, SALSA, etc. Previously at IBM Research, Brandon worked on various security areas such as container content protection via encryption and image signing, identity, and kernel attack surface reduction. Next. Parth Patel, CPO and co-founder of Kasari. Parth focuses on bringing transparency and security to the forefront of all projects. He's an engineering leader with more than 15 years of cybersecurity, DevOps, software development, and automation experience. Parth's an active member within the open source community, serving as co-creator and lead maintainer on the GUAC project, and a maintainer for the CNCF Intono Attestations, CNCF Ontoto Golang, and Fresca projects. He has successfully led multiple consulting and development projects for modernization, migration, cloud adoption, and a secure software supply chain, including with government contractors where security was paramount. Next. Finally, we have Umang Jain, Director of Technical Program Management, Platform Engineering, Guidewire. Umang Jain has been with Guidewire Software more than 6 years as the Director of Technical Program Management, Platform Engineering. He's worked with agile software practices for more than a decade. His passion is ensuring platform engineering teams to be effective partners with application developers and shipping software features. Next. All right, so each of our panelists have 5 minutes where they're going to help us get a much better understanding. And our first panelist is Rose. Rose, take it away.
Okay, thanks, David. All right, so in order to understand how an SBOM relates to open source security and to GUAC, we first need to establish what an SBOM is. And I'm assuming that at this point in time, among the explosion of SBOM requirements and executive orders and tools, that most of us have some level of understanding about what an SBOM is. So maybe you're even generating or consuming them in your own workflows, but at a high level, you can think of an SBOM as the famous list of ingredients for your software. It's a formal record of the, and can we go to the next slide too? Sorry. There we go. It's a formal record of the components and processes used to create a piece of software. So if a software artifact was a cookie, an SBOM would tell you not only that there's a stick of butter in the cookie, but also who supplied that butter and the ingredients that were used to make the butter. Right? So as far as what's inside the SBOM, you'll see general information about the software itself. So things like the name, version, supplier, license, checksum of the software that the SBOM is describing. And the way that you use your SBOM will likely inform some of this information, right? So if you only care about an SBOM for inventory purposes, then maybe it doesn't contain license information, as an example. A complete SBOM will also contain a list of dependencies. So again, with that general set of information per dependency. So each dependency will also have information like its name, its version, checksum, etc. And most importantly, relationship information for each dependency. So for example, the SBOM tells you what package pulls in that specific dependency, and does that dependency pull in other dependencies? This relationship information is important because it helps tools like GUAC create that knowledge graph of metadata. And then finally, an SBOM should contain relevant applicable references, which may include things like URIs, attestations, maybe a reference to external supplemental information like a VEX document or another SBOM, and potentially even outlining known unknowns in the software. So next slide. Okay, so we're told that having an SBOM is important, making sure that your SBOM is complete and accurate and actionable. But why do we really need this SBOM document? And first and foremost, an SBOM is fundamental for software transparency. And software transparency is important because transparency builds trust, especially now in a time where security and supply chain health is top of mind. It's really important that software producers and consumers can both trust the software on which they depend. So SBOMs can help build this trust by highlighting precautions software producers are taking to create quality, secure software, and software consumers can use an SBOM to validate and verify the software they received. So trust kind of gets built on both sides. SBOMs can also be used for basic software inventory. So both for security and compliance purposes. From a security perspective, having a record of the components contained in your software can help you do things like check for vulnerabilities in the dependencies that your software relies on. On the compliance side, the inventory list of components can be used to check for compatible licenses in your dependencies, making sure you're not including restrictive licenses that might affect usage or distribution of your software. And then from a supply chain security perspective, SBOMs can help us contextualize risk, both around the quality of components and their provenance. And this kind of parallels that idea of inventory, right? So if you have a record of the components in your software, you can perform risk analysis much easier than if you didn't. And risk here isn't only vulnerability related. You can also do things like check for stale or end of life components. And then on a similar note, SBOMs can be used to determine a vulnerability's applicability. So it can help you answer the question, does this software contain a dependency affected by CVE 123? Has it been remediated? Of course, you can't determine if you're affected by a vulnerability until you actually inventory your software with that SBOM. SBOMs may also be used for things like security audits. So especially at large companies where security breaches and supply chain attacks have big implications for not only customers, but shareholders. You know, these companies want to ensure that their software is safe, secure, private. And one way to make this guarantee is to regularly perform security audits of software or services. And SBOMs contain metadata that can make this process easier. Ultimately, the existence of an SBOM doesn't do anything on its own, though. It can inform you of many things, but it doesn't turn that information into action. Actionable policies must be put into place for an SBOM to create real utility. And what those policies look like will be specific to your organization and your use cases, but having that SBOM for your software can help you get started implementing your security and risk assessment policies in a proactive way, which is what this talk is all about, right? So that's all I have for today, just the SBOM primer before we get to GUAC. And with that, I'll turn it over to Brandon and Parth.
All right, next slide, please. So to start off, just kind of showing off a illustration here is like, supply chain dependencies, everything is very complicated. There's a lot of components out there, right? The software you build, even if it's like a, hello world, it might end up pulling in dependencies, you don't even know about, right? So there's lots of things coming in. So it's a very complex or, complex environment, and it continues to grow, right? So coming from the defense contracting space, right? Like there was always lots of hours were wasted on just trying to understand what's happening inside the environment. So starting off, right, like we were pulling in, trying to figure out which dependencies we can use. There was a whole manual process in terms of determining, hey, should this be allowed? It would get sent off to this organization, which would do some kind of testing, and then it would come back with yes or no, and we don't know exactly what kind of testing they did. And it was like a one-time test kind of thing. And then yes, it's allowed. But there's no continuous, checking of open source dependencies like that are coming in to make sure, like, the maintainer hasn't gone rogue or stuff like that, right? And then, even then, when new vulnerabilities got introduced, right, we're always in the process of trying to figure out, okay, where is this being used? First of all, like, where am I affected by this vulnerability, and where exactly in my ecosystem am I affected, right? So if I'm doing a scan of an individual thing, but I want to know comprehensively my whole software environment. If there's a vulnerability, I want to pinpoint it right away so that I can go fix it, right? I don't want to. There was a lot of time, again, being wasted scanning things. So if a new vulnerability comes out, there's a lot of churn in scanning and trying to figure out what exactly is going on. So taking all this information, taking SBOM information, taking all this other metadata that's out there and combining it together can help us a long way in terms of figuring out exactly what is in our ecosystem. I'll pass it off to Brendan and then continue forward.
Awesome, thanks, Parth. Next slide, please. So as Parth said, we come from a place where visibility into things have not been great, and we're glad to say that over the past years, the industry and the open source community has made many big strides in this, and we are blessed with the ability to have a lot of metadata available to us today. This is great. It's great to have that information and knowledge as power, but it also can be overwhelming at some times, especially if we don't know what to do with them. There's so many of them. Like, how do we put them together, right? And so let me just chat a little bit about the different types of metadata that we have today. And we have SBOMs, also VEX, scorecards, CVEs, etc. and each of them, they're not like duplicates of each other. They provide a unique piece of the supply chain puzzle for the security of your software supply chain. I've been inspired by Rose on chocolate chip cookies, so I'm gonna try and create analogies for the metadata for each of them. So we in this alphabet soup of different metadata, let's talk through a few of them. So we have SBOMs that Rose talked about, SPDX and CycloneDX examples of that. Like Rose said, here's a chocolate chip cookie. What's in it? Who provided it? Like, this is a general standard ingredients list. We have something called Salsa, which is an OpenSSF project that tells us about the integrity and provenance of the software. Was it created by a trusted builder? Has this piece of software been tampered with? We can think about this in terms of like, do I know which cookie factory this comes from? Or if we're baking the cookies ourselves, was this made? Which oven was this made in? Or which microwave was this made in? And maybe I don't trust microwaves to make my cookies. Potentially controversial. And then we have CVEs, right? Like, the CVE may tell us what software is vulnerable. In this case, maybe you say, like, if you take a cocoa seed and eat it, it's probably not good for your digestion. And then we have this thing now called VEX, which was introduced more recently within the past 1-2 years, which tells you whether or not a piece of software is actually exploitable. Right? For example, you may have a component that has a vulnerability, but you're not using the function that contains the vulnerability. So in the end, you're not able to be exploitable, and therefore, your vulnerability report may say, "Oh, you're affected by this CVE." But in actuality, like, if you didn't call the function, there's no way that you're exploitable. In this case, yeah, like, we ferment and cook our cocoa seeds, and therefore they're more edible. And finally, we have scorecards, another OpenSSF project, which tells you a little bit more about information about the projects of dependencies that you're using. So it tells you a little bit more about the maintainership of the project, the CI best practices, and a whole range of other signals. So next slide. So all this information is great, but like I said, more often than not, we don't have a way to put all of them together, and we want to make meaning out of that. Next slide. Right. So we talked about metadata, but how do we actually put this together? We don't want to just like grab metadata off the internet, or just like someone's hard disk and be able to do something with it. We have to be able to trust the metadata, right? Because in the end, we are making security decisions such as, should this run in my cluster? And if we don't trust the metadata, we might as well not trust kind of like the applications that we're running. So a version of this slide was presented in the OpenSSF supply chain integrity working group. And this shows like the 4 layers of the supply chain integrity framework, starting with the bottom, trust foundations, attestations and metadata, aggregation and synthesis, and finally policy and insights. So let's start from the base of this, right? Since we're making security decisions about metadata, we need to be able to trust it. And that means we need a good trust foundations. So examples, OpenSSF has a project called SigSolve, which provides simple signing solutions and a publicly verifiable transparency log. And to be able to ensure provenance of builds, we need workload identity and signing. And this can be done with technologies such as Spiffy and Spire. Now, with these signatures, we now have a ton of metadata. And what do we do with it? Right. So this middle layer, we talked about SBOM, Salsa, VEX, and that's where aggregation and synthesis comes in. And this is taking all the trusted metadata, making meaning out of it. And finally, what do we do with this meaning that we found from putting them all into a supply chain knowledge graph? We want to be able to insight action. We want to be able to make the right security decisions and make the right security investments. And this is where this aggregation and synthesis layer is where GUAC is, and this is kind of the gap that the GUAC project is filling. So I'm going to hand it over to Pav to tell you more about GUAC and what we have in the pipeline.
Awesome. Thank you, Brendan. So going behind the scenes for GUAC, right? So like Brendan spoke about, there's a lot of metadata out there. So what GUAC is trying to do is trying to combine all this, decompose the SBOM, for example, into the different dependency relationships. If there's scorecard information associated with the specific repo or specific project, if there are, is there vulnerability information, is there VEX information, taking all this information and, decomposing in a sense that it can be created, decomposed and then put together into relationships and so that it can be usable for policy checks, for patch planning, or identifying critical infrastructure. So behind the scenes, what's happening is GUAC is parsing all this information out from all these different data sources and then putting all this information into a graph database. So it's not a static database. GUAC is a very much of a living database. It's always trying to find more information, pull in more information. So for example, there's another open source, there's another tool out there created by Google called deps.dev, which provides you more open source, if there's more transitive, if there are dependencies for these open source projects that you may not have in your SBOM, it tries to fill in the gaps and add that information in. It's collecting threat information from, OSV, which is another open source vulnerability scanner, and as well as a database. So it's pulling a lot of information in. And that's always being continuously updated. So like, let's say, one day a package may not have a vulnerability, but then the next week it could, right? So we always want to have that updated information. So constantly GUAC is always in the back end, always trying to evolve, always trying to learn more information. And as more data gets ingested, right, those relationships and all those kind of things get built out even bigger, and you have more understanding of what exactly is happening in your software environment. So like I was saying, it's like, if there was a vulnerability does come out, right, then you want to know exactly, I don't want to be scanning all my software. You can ask GUAC via the API. We have a REST API. We also have a GraphQL API. So you can ask GUAC to be like, where am I affected by this vulnerability? And it's going to give you the full output of like, okay, here are the different projects that are using this vulnerable package, and what is the most effective way to actually go patch this, right? Whether it's part of the base image or whether it's in a specific layer within your Docker file or whatever, like you can go find all this kind of information out. Next slide, please. So what GUAC is trying to do is allowing you to be proactive, right? When the next Log4j or whatever other kind of critical vulnerability comes out, you don't want to be scrambling, right? A lot of companies, a lot of organizations, when they have a lot of software, running in their environments, when Log4j came out, they were stressed out. Like for a month straight, I think people were scanning their environment, trying to figure out, okay, where am I affected? What needs to be done? All those kind of things. So when the next time something like that happens, you want to be proactive, right? I want to know exactly what's happening in my environment because you have the data right there, right? And you can quickly answer the question, where am I affected? And then at the same time, you want to be preventative, like, what have I taken the right safeguards? Are we, is there salsa? Is there vulnerabilities? All those kind of things that are there so that I can be running in production. And then finally, if I am affected by something, when a vulnerability does pop up, we can answer the question right away and we're kind of set to go. Next slide, please. So the latest update, right? GUAC is now an OpenSSF incubating project. We just had our latest release, 0.70. So we now have a full Postgres support actually in the backend. We're using Postgres, but it's acting like a graph database. We also have other backend supports that are supported by the community, such as Orango. And then we also have like a key value in memory one just for testing and all those kind of things. We have a strong community of 300 members. And, we have the contributions have constantly been growing. A lot of other open source developers have jumped on and kind of seen the importance of this and are helping us build this out. So every day we're growing in number of contributors. So we're looking for more as if not even if you're not if you're not technical, you want to come in as we have our documentation site, we have our whole own landing page, so adding more information, adding creating demos, whatever else it is, we're always looking for more contributions. And then finally, we're in the OpenSSF Slack, we're in the GUAC channel, and we also have our community meeting, and it's on the OpenSSF calendar, so it's on the third third Thursday of every month. And we also have a website. Next slide, please. I'll hand it off to Umang to talk about GUAC from a user perspective.
Okay, thanks, Parth. Hello, everyone. I'm Umang. I am representing Guidewire, who's started his journey on the securing the software supply chain and is an active user of GUAC right now. Can we move to the next slide, please? So very quickly, Guidewire is an established enterprise in the insurtech space. It's a leader. Traditionally, we've been in the on-prem world, helping our customers, which are property and casualty insurers. And gradually, we have very rapidly, rather, we have moved into establishing ourselves as a cloud provider, where we are supporting all our customers on their extensive workloads around policy, billing, and claims, and all the new services that we continue to discover. I'm representing the platform engineering team, which is responsible for creating these internal developer platforms that subsequently power all our products, which eventually our customers love. Move on to the next slide, please. Very quickly, how we ended up using GUAC. I mean, we are on board with the problem that software supply chain attacks are continuing to be on the rise, and every responsible software vendor must be preparing itself against that threat vector. This problem came down to the platform engineering in terms, because we are responsible for providing the security out of the box on our platforms. And when we looked into the space, we started leveraging Salsa to drive the evolution of the journey. I think it won't be wrong to say that as we are evolving, we are standing on shoulders of giants, right? With Google, Kusari, and others who are sort of like leading the way and defining how the roadmap should be, and we're trying to learn from them and figure out, okay, what is it that will be relevant for our journey, and what questions are relevant for us right now at the moment. And specifically, GUAC came into picture when we were looking at the problem of aggregation and synthesis, and very nicely put into that slide before, Parth and Brandon, like that distinctly calls out where GUAC is. I think we had a few confusion in terms of like how is GUAC placed in terms of the spectrum of things. And before landing on GUAC, we were trying to develop this solution ourselves in terms of like, okay, we needed a place to ingest the data. Maybe we'll figure it out ourselves. And then we started answering the questions. Okay, what is it that we would want to answer from this data that we are ingesting? And one after another, we started realizing, oh, this is like a huge problem to solve. And with the limited capacity that we have, we might not be able to solve it. And I think right then and there, I think we became aware of GUAC as a possible solution, and I think that that interaction really helped us move forward and pivot into adopting GUAC. And because I think it integrates well with Salsa, and I think the direction in which they were headed aligned with what we were trying to do as well, right? Moving on to the next slide, please. So very quickly, we've just started the journey a couple of months back. And where we are actively just focusing on demonstrating ability to generate the necessary artifacts, SBOM, provenance, in acceptable formats, and which then can be available for better decision making, like it was mentioned by Brandon, right? I mean, and Rose, like the key is not just to ingest; it's essentially it is to make better decisions, to implement better policies, and we are going through the spectrum end to end to be able to say, okay, given, can we generate artifacts? Can we store it and in a way where we can extract the information meaningfully, and then set policies on top of it to be able to say, okay, leveraging the information that is generated. That's where we are, and the harder parts are to integrate all of these into our evolving platforms. And eventually, we want to, in the next step, we do want to move into leveraging the insights that GUAC is generating. I mean, we are ingesting all the data, but how do we make better use of all of that? So that will be our next focus area. Moving on to the next slide. And very quickly, just wanted to share the journey that we've had so far working with GUAC. So as I mentioned that we decided to leverage GUAC and pivot away from bespoke solution. And I think getting started was easy. As I look back, the documentation was easy. And as the team reviewed this page again, they felt that the documentation was significantly improved as well. And I think anyone new who's going to be adopting GUAC now will find it very easy to pick it up. Next. So, and then very quickly we realized that, the underlying database that GUAC uses is probably not going to be supported per our company policy. So we wanted support for ArangoDB. So we forked GUAC and started working a little bit in developing support for ArangoDB. Next. But then this is the beauty of working with a great partner, right? With like Kusari, right? And we shared our problems while we continued a journey, and very quickly GUAC supported ArangoDB natively, and which is when we decided to get back on to GUAC journey and leverage the native SDK provided by GUAC. Next. We did continue to have a little bit of challenges when we started upgrading to the versions of GUAC. Sometimes collections were not assumed compatible with the upgrades, and that continued to drain a lot of time from our teams. Next. But I think that's where, again, the beauty of working in a community is, right? I mean, and to be honest, right, I did not have that background when working with this team. I mean, internal teams, in terms of like, how do we support open source here, and how does it help us move faster, and what is the whole value of having great partners? I think with a couple of pull requests that our teams shared, and the collaboration that we got, I think we solved some of these problems that were affecting us. And today, as we speak, like upgrades are easier for us. And I think we have resolved some of the problems that we were facing in our journey. And I think so far it's been great partnership that we've enjoyed. So that's where I think we are at Guidewire. Over to you, David.
Yes, thank you so very much. So first of all, I want to, again, thank you, give profuse thanks to our panelists for being willing to spend some time sharing their knowledge today. So really, really appreciate that. So I've got a couple questions I'm just going to tee up to the panelists and kind of get things going on some questions. And then I'm going to go to some of the participant Q&A, public Q&A session. So if you've got a question and it doesn't seem to be answered, please go ahead and add that through the Zoom Q&A. So let me start with, I understand that there's a funny story about how GUAC got its name. Any of you want to volunteer some of the behind the scenes how it got named?
Yes, I can start. I think so. GUAC. There's already Salsa when GUAC, before GUAC came out. So Salsa was, right, as Brendan talked about, the build provenance piece. And then at the time, a couple of us were also working on another project called Fresca. So there, we had Salsa, we had Salsa Fresca. So then I was like, okay, and then we started another project, and we all came together again. It's like, well, okay, let's call it GUAC, right? So like, just to put with the theme of things. So that's how the whole became all the condiments kind of came together, kind of thing. So, and I think later on, I know that another project came out called Tacos, which just came after GUAC. So I think everyone kind of started following the same kind of naming convention, and I think now people, I think hopefully, when you search in Google now, I think there's guacamole shows up, and then also GUAC kind of shows up in OpenSSF, so it's kind of strange.
Awesome. Okay. Nothing else put a smile on our faces here. So can any of you talk further about some of the use cases for GUAC? We've talked about some things that it can do, but a little further down on some of the use cases specifically.
Yeah, I think there's a couple. I think one of them is around just SBOM generation is hard. And most of the time, a builder knows what it's building, but generally, well, a lot of the time, you're building a container image, you do like copy binary into the image, and you don't really have that insight into the transparency there. And so like one of the things that we can do with GUAC is say that like, okay, having SBOM, I'm gonna use salsa because I know where all the ingredients came from, and I collect all the SBOMs together and put them in. Another use case that I think we see a lot in common is like patch planning, and the idea is like whenever I get a vulnerability, the person I filed it to is always the product owner. And sometimes the product owner is like, I have no clue where this thing is. And that's because of like, PowerShell, that huge massive dependency tree. And, there may be multiple teams, multiple layers, upstream, open source, and even within open source, like multiple transitive dependencies. And having the patch plan that tells you, okay, like you have to fix this first, this next, and kind of help communicate kind of like that vulnerability filing and patch plan has been, I think, one of the use cases that we've seen pretty often.
Anyone else? Okay, as was mentioned earlier, this is not just one person. There's a community here. Can you tell us a little more about the community, some of the folks that you're working with, the people are working together in GUAC, in the GUAC project?
Yeah, I think so. Some of the notable names I would say are, for example, Red Hat, Microsoft, and Yahoo. So I think Red Hat kind of joined us a little bit early. They also saw the need for the space, and they started contributing. They were the ones actually initially who built out some of the Postgres backend pieces, and then introduce, the Vex implementation pieces. So I think we were still building out the vulnerability on other components, and they came in and it's like, hey, there's a lot of importance around Vex, so we should incorporate those kind of, with CSAF and all the different types. There's Open Vex. There's a lot of different types of Vex types out there. So like we should incorporate all those in. And then Yahoo came in with other ideas, with other use cases. For example, like they wanted to SBOMs sometimes, depending on how it's been scanned, they could contain layer IDs for specific on image scans and so forth, right? So you could map the layer IDs. So let's say, a specific particular package is vulnerable. You can map it to the Docker config and find out exactly where in your image you're actually affected. So you know exactly which layer you have to go fix. Whether it's a base image or it's a specific piece in your Docker, your Docker config that you have to go fix up. And then Microsoft kind of came in also. They were very interested. We're still figuring out this use case in terms of how this would all fit into GUAC, but in terms of like how, adding a is deployed kind of a node within GUAC. So meaning that like if there is, tying things. So once you have an SBOM, once it's been created, and then part of the CI pipeline, let's say it gets pushed into production or whatever else, right? You want to know exactly where did it actually get deployed? Did it actually get deployed, or where is it exactly running? So it's not a full on, where is it running kind of thing, but it's more about like, yes, this specific version got deployed and is running out there, right? So, GUAC, we don't want to make it a real-time database where it's like, constantly checking to see if you're running, because that's, it's too much information, and that's outside the scope of GUAC. But you could have agents and other things that kind of keep track of this, right? But at least knowing that, yes, a specific version has been deployed and is running based on the information that got collected, is running out there in the environment.
Yeah, I think we also got some contributions from the same team, Microsoft, on like OCI registries, right? I think this is one of the I think the things that we like about the community, we've gotten PRs on like, oh, let's add like a scorecard kind of passer and certifier that was done by independent contributor, and also like improving the OCI collector. I think these are standards, and like see, not only there's different types of metadata, but there's also different types of repositories, different types of like endpoints, and they all work differently. And I think this is why one of the main reasons we're like, yeah, this would be great as an open source project, because we're constantly having to develop with the community as well.
Okay. So let's obviously got a lot of people here with a lot of expertise, but some of the folks joining us may not have a lot of background in this. So for those who are relatively new to this discussion on open source software security and they're just encountering GUAC for the first time, how would you suggest they kind of start? Because there's, I'm sure they're probably getting a little overwhelmed with all these references to projects and so on. Anyone?
So I can start off. I mean, I think one of the main things I think this to start doing is start generating data, right? Start generating SBOMs, start generating, whether it's a Vex or Salsa, whatever, all this metadata that's out there, just start generating them, right? Because right now it's a black box. Right now, without data, you really can't, you don't have that transparency into your environment. Once you start generating this data, you can answer a lot of questions. So I think the main thing right now is like, before GUAC, before all these other things, there's tools out there. There's a lot of tools out there that will generate SBOMs for you, right? That are either ecosystem specific or they can just be, they're general and it'll work for everything. And it could be either CycloneDX or XPDX, whichever it is, right? Whichever you explore both and just start generating data. That's what I would say.
Yeah, and if I can add, I think from Guidewire's perspective, we followed a little bit of similar approach too, right? Except that there were a few things that we had latched on very quickly. So what we really benefited was, I think, since we decided that we'll go with GUAC, we spent a lot of time on on a GUAC docs, and I think there was a section that our engineering team really leveraged that which talks about how do you take a basic SBOM and a provenance artifact and ingest it? And I think as our developers, right, we were spending a lot of time in understanding what does that really mean? What kind of artifacts are there, right? And when it is ingested, what does that look like? And then you layer salsa and guidelines around what are we trying to accomplish? But where will we find those artifacts? How close are we to generating it? Or what are the good tools that can generate those? And I think bringing those things became very easy when we started navigating it this way. Like use whatever is available as a sample data at GUAC, test it out, look at this format, spend time there, and once we've seen those artifacts and learn a little bit more about then the underlying tool, like okay, well, how the decisions are being made. I think that even though some of us were approaching it from a business perspective, as engineers on our team, they found it very easy to understand, to associate technology with the kind of business need.
All right.
I think that.
Oh, so go ahead.
No, I just also add, I think, a quick thing that, like, I think also one exercise that I found useful sometimes is within your organization or just within your a pipeline that you want to look at. It's like, try it by hand and see what happens. And sometimes like you realize the information is there, it's just not being propagated, or it's not being put in the right format, it's not being included. And that goes a long way. So
awesome. Well, we've got a whole bunch of questions from our participants. Thank you. Those who sent in questions for our Q&A section. So I'd like to jump right into that. I don't know if we're going to have time for all of them, but let's make a stab and we'll try to answer what we can here. So I think that this is actually the first one we got. Can GUAC extend the metadata of raw data provenance used to train machine learning models? So it's metadata about the final machine learning model artifacts. So machine learning models. We should answer that sooner or later. So let's talk about that.
Yeah, that's an interesting one. And like I think I was talking to one of my colleagues in this that's working on the AI, basically the AI guidance, right? The SSDF equivalent for AI, and we were talking about it. And it's like, yeah, code's code, data's data. It should be handled the same way. That given, so Mihai, one of our maintainers, is also, I think, on the call. He works on AI model transparency. He's also maintainer on TensorFlow, and now working on model transparency. I think in general the shape is the same. I think we need the same type of pieces. Like we need provenance, we need data integrity, we need all that. Now the graph may look a little bit different because like data lineage is more important in those cases. So we may want to have like more scrutiny on the data, different type of metadata on the data itself. Another part of that is also hashing. Model hashing is very different. But in the end, those are like, I think, like the bits and pieces of the bigger picture, right? It's like you're not using SHA-256, you're using some other hashing algorithm. You're not having like you're having SBOMs with different fields. I know, yeah, there's several different, a little bit of different fields, but in the end, the shape I think takes about the same.
Yeah, I think we do want to do a POC. I think there's a lot of interest around this, so I think we're going to talk about it, and I think we see how this kind of fits into GUAC and how we can do have a proof of concept. And once that's there, I think we definitely want to publicize it and kind of show it out there. But I think there's plans around this.
Okay, excellent. Okay, so are there any plans to introduce a user interface or front end? Obviously, many people can use CLIs or APIs, but I see a case where less technical users or non-technical users would prefer that instead.
Yeah, so there we did, right? So we do have the GUAC visualizer, and I think that the person that asked the question is aware of it, looks like. So we are all back-end developers and engineers, so we were terrible front-end. So we started doing some of it. That's where the GUAC visualizer came to be, right? And we, it fell apart pretty quickly. It was very, very, like not optimized, and it took us a long time to put out features for it. So we were like, okay, let's focus on the GUAC piece. Let's get the, what we're experts in. Let's get that piece actually figured out. And then we were hoping, we definitely want community support around this. Like and there was some chat in the community channel already around like, hey, there was like, I think one of the Red Hat folks actually put like an outline together of like what it should look like. But nobody has the expertise to actually go do it, all the maintainers. So we're looking for community support on this actually.
Okay, anyone else? All righty. How does GUAC deal with dynamic dependencies where the operating system provides them and you won't know the version of the dependencies without looking at the environment it runs in?
I think that's a good question, and I think this comes down to I think today a lot of the metadata, especially like the SBOMs you get, I think the community came together and described the different SBOMs, right? It was like source SBOM, build SBOMs, deploy SBOMs, runtime SBOMs, and I think a lot of what we see today is like the source, build, and this analysis SBOMs as well. And those are the three types of SBOMs that we're seeing. Now there is a question of like, those SBOMs generally tell you just like anything that's statically linked into it. There is facility, and Rose can keep me honest here. There is facility in SPDX to say something like, I'm depending on a dynamic dependency here, and say like, I can't specify this obviously because it's dynamic. But yeah, I think this still relies on the environment gets put in, and until we get this like deployment / runtime SBOMs, those will also then fit nicely into the model. But I think right now we don't have the ability to do that because we don't have the data that's actually flowing down from that as well.
Okay, awesome. Anybody else? All right. What are some of the challenges around SBOM, and how does GUAC overcome those challenges? And I probably want to narrow this down. What are the challenges that are relevant that to GUAC that GUAC tries to overcome?
Pop, do you want to take this?
Yeah, I mean, SBOMs, depending on the tool you use, right, it could generate different information. It could be missing information and so forth, right? So what GUAC tries to do is it tries to it tries to account for all these different tools, right? So if you're generating via different, whatever tool that's out there, whether it's ecosystem specific or not, right, it's going to give you either more information or less. I think this is evolving, right? So I think as time goes on, SBOM quality is definitely improving, right? But I don't think we're fully there yet. So what GUAC tries to do is that it tries to, that's why we're pulling in information from like deps.dev and other pieces. Like, can we fill in the gaps? Can you fill in missing information? In cases where, per the spec, maybe it could be valid, right? But if it's like critical, like, hey, if it's missing like the top level component, for example, right? What is this SBOM actually describing? If that's actually not in there, then like, what is this SBOM actually useful for, right? So if it's some stuff like that could, like, if that data is not there, then GUAC's gonna reject some of these SBOMs because they're like, even if you ingest them, like what good is it to you? Because it's not really giving you any information. So it's all about in terms of how, SBOM quality. And we try to, it tries to assess GUAC, as it's processing some of this stuff, it tries to assess that. And if it's, if critical information is missing, then it's going to reject that SBOM, for example. But I think a lot of these tools now, I think we're seeing less and less of this actually as time goes on. Initially, when we started out, there was a lot of things, a lot of churn, but now with the SBOM tools kind of stabilizing and getting better, we're getting good amount of information in, and I think we'll continue to see that improving as time goes on.
We will keep filing issues on on tools. Yeah, I think like Pop said, we've come a long way. Software identifiers I think still continues to be a very tricky topic. I think there was a CISA document kind of talking about it sometime last year. The GUAC maintainers also provided a response to that, and I think there's something that we can do better. GUAC kind of like PubSit has its own data model on packages because if you take an OCI pull and a Docker pull and try and look at them, the identifiers are kind of structured differently. And so it'd be like, oh, this field and this field are actually kind of referring to the same thing. And therefore we kind of do additional processing on top of that.
Awesome. Anyone else? All right. I suspect we're not going to have enough time for everybody's questions, which I'm sad about. But I love this question, so I'll ask this one. So I'm keen to contribute to the GUAC project. Can you elaborate on the current area where community contributions are most needed? Are there specific or components or features that are prioritized in your roadmap? So thank you for our questioner. I'm going to immediately bring that to our panel.
So I think we're version 0.70. So one of our priorities is to get to 1.0, right? So that it's more publicly, public can rely on it. Organizations, feel more comfortable using a 1.0 product, right? So I think our goal is just to is to do more testing. There are pieces that are missing, and I think we try to go in there and create issues, mark them as good first issues, and mark them as like. I think we do need to do some updates in terms of tagging things like for the next release, for example. So once we do that, I think that the community can jump on board. But I think at this point we're looking to have more users jump on board, test things out, give us feedback in terms of like, hey, this is not right, this is not missing. If they want to see, and I think there was a question in there, how integrations. There's like if there are more integrations, like where we have OSV, we have deps.dev, but GUAC is very pluggable. So if there are specific use cases that you would like to see, like other integrations you would like to see added on that that are not included currently, then please do so. Right, that's what the whole point of GUAC is that it's supposed to be pluggable. You can add in more information as you see fit. So it's meant to be it's meant to grow out. So if there's specific information missing or specific integrations that are missing, we can always do that. Other piece is we want to see more specific queries developed, right? So we have a REST API, we have a GraphQL. So if there are specific questions, all the data is there, right? So now it's basically massaging the data and getting the output you want. So it's like, is there more use cases that the community would like to see? And then we can and then the community can help us incorporate those into the REST API. So, users can ask the question and quickly get the answers back that they want, or, with the GraphQL. So all this stuff, right? And then there are integrations, right? So there was a talk that I did at KubeCon EU is like I integrated this with with one other person. We from Red Hat, we did an integration with OPA, right? Open Policy Agent, where it's querying GUAC for information, so we can use that as an admission controller, right? So it's the admission controller OPA is querying GUAC for information, and it's asking it like, hey, I'm running this image, I'm going to put it into production, for example. Is it allowed? Like based on my policies, am I allowed to run this, right? So was there vulnerabilities? Is there an SBOM? Does it need salsa? Whatever else, right? There's a lot of things. So you can ask those kind of questions and get that answered.
Okay. All right. So sadly, the clock is once again tyrannical, and we've run out of time before we've been able to answer all our questions. We do plan to answer the ones we're able to get today via blog post. We are going to post the video as well. I just want to quickly, once again, thank our panelists for sharing their knowledge. We really appreciate it. Let me give some quick context and other things. I mentioned earlier, OpenSSF has a number of courses. One of those is the Developing Secure Software course, LT 121. It's free, entirely online, and most software developers have not really had any significant training on how to develop secure software. And this is a way to gain the knowledge that's really vital in today's world. Next. We have some upcoming events. There's the SOS Fusion Conference in October 2024 in Atlanta, Georgia. The call for papers as well as registrations open. There's also the LF Open Source Summit Europe and SOS Community Day in Europe in September in Vienna. Links are there. Next. There's lots of ways to participate in the OpenSSF. You can join working groups and projects, come to meetings. We've got Slack. You can contribute on GitHub, become an organizational member. We've got a mailing list. Please, please, please do consider participating. The more people are involved, the better everything is for everybody. Next. We've got lots of ways to engage us on social media. X used to be Twitter. We got LinkedIn, Mastodon, YouTube, Facebook. There's ways to connect into all those places. Please do subscribe to our mailing list, openssf.org. Whoop, go back, not quite. /sign-up/sign-up. Not massive volume, and we'll keep you up to date on what's going on. And please, when you get that information, please reshare it with those you know within your organizations, your companies, your projects as relevant, because there's lots going on. Next. Is your organization a member? If it's not, please contact us, openssf.org/join or membership@openssf.org. Next. And finally, thank you. Thank you to our panelists. Thank you to everyone here who's participated. We are really, really grateful for your time. Please do take our quick little Tech Talk survey. This gives us feedback on how to make improvements. We've tried to bring in improvements and ideas from the past. I believe that almost anything can be improved. So we welcome your feedback. Let us know how we're doing. Are we doing okay? Suggestions for improvement, all that sort of thing. So I think that's our last. Yes, that is our last. So once again, thank you very much to all our panelists. We are very, very grateful for sharing your time and expertise. Thank you very much.
Thank you, guys.
Thank you.
Thank you.